In this video, we're going to be solving a free fall kinematics problem, and we have a ball tossed upwards from the ground and it lands on the ground 3 seconds later. What is the initial velocity and maximum height of the ball? Now, what makes this problem fairly difficult is that there is very little information in this problem. It literally only tells you that it's in the air for 3 seconds in total. So that means that you need to know your free fall concepts very well in order to solve for these variables. So let's go ahead and solve for the initial velocity first. And in order to do that, we're going to need to find 3 different known variables in order to get that. Now, that's going to be a little bit tricky. So let's go ahead and talk about some concepts. We know that if you toss something up and it goes all the way up to its peak, we know at the peak it has an instantaneous velocity of 0, and then it comes back down. If it comes back down to the same level, then its initial velocity is the same as its final velocity, except the final velocity is negative because it's headed downwards. As it's rising and falling, its acceleration is negative 9.8 meters per second squared, as is the case with all free fall problems. And then in addition to that, we know that the total time in the air is 3 seconds. Now we're looking for that initial velocity, and for this one, you need to do a little bit of a substitution here, and I'll show you what I mean in a second. So we don't quite have 3 known variables. So if I'm taking a look at my different formulas, this one we can't even utilize the t, so I'm not going to use that one. This one is independent of time. And then I have the first one and the second one. Now, it looks like I could maybe go either direction, but because this one has a t over here and a t squared, I'm going to take a look at this first one. That means that looks like the most simplistic version that I could use to find the time. So if I set it up in the first formula, it's going to look like this. And what we're going to have to do here is we're going to have to do a little substitution because we have 2 unknown variables. We just want that VI. So what we can do is this. We can go ahead and say that our So what we can do is a little substitution here. So we want this VI, but we actually want to get rid of this VF because now we have 2 unknown variables. But we know that VI equals negative VF, and then also vice versa, negative VI would equal VF. So what I'm going to do is I'm going to do a little substitution and then grab this negative VI and then drop it in over here. So if it's negative VI minus VI, then it's going to be negative 9.8 equals negative 2 VI divided by 3. And then all I'd have to do is multiply both sides by 3. So I'm going to basically just cross multiply that 3 over there. And then after that, I'm going to divide both sides by negative 2. And that should give me my answer. So 3 times negative 9.8 is negative 29.4. And then if I divide that by 2, that's going to go ahead and give you my answer, which is going to come out to 14.7 meters per second. And now I have my VI. So you definitely had to know your concepts very well in order to solve for that one, especially using this little substitution right here. Now for the second part of the problem, we want to find out what is the maximum height. So we only want to go from the bottom to the top. So we now know that our initial velocity is 14.7 meters per second. So that's really helpful. We know that the final velocity up top, our instantaneous velocity at the peak, is always 0. And if we wanted to, we know our time is 3 seconds total. And we can go ahead and split that in half and then say that the time to rise is 1.5 seconds. In addition to that, we always have our acceleration, which is negative 9.8 meters per second squared. So if we wanted the displacement, we could use this formula over here because this one has a delta x in it. And then we can use this one over here because this one has a delta x in it. So really you could use either one. So I'm just going to go ahead and grab this third one over here. And what I'm going to go ahead and do is plug it in, and it's going to be 0 squared equals vi squared plus 2 negative 9.8. Instead of delta x, we'll just call that delta y. So 14.7 squared is 216.09. And so I'm going to subtract that from both sides, which is going to cancel it here and then send it over to the other side. And that equals 2 times negative 19.6, or 2 times negative 9.8, which gives me negative 19.6 as the coefficient in front of the delta y. So if we go ahead and divide both sides by negative 19.6, that should give me our final delta y. And our delta y, which is our maximum height of this ball being launched, is 11.03 meters. Now, these two problems had a lot of conceptual stuff in there. So once you get to the mathematical part isn't too difficult, just working some numbers around using a little bit of algebra. So you definitely want to draw out your scenarios and write down all of your known variables. Write down everything you know, including major concepts such as this right here, VI equals negative VF, because you never know when you're going to use a scenario like that. So I hope that was helpful in helping you solve these two free fall kinematic problems. Thank you for watching and listening.